All right, my name is Kevin Street, and this is my midterm presentation for computer networks for Christine Wibowo's class. This is for chapters 1 through 6 of the semester so far. So the first chapter was about introduction to networking. The main part of this is there's two main types of network models. Peer-to-peer is used for small, simple, low-security networks. Client server is used for centralized and more secure networks. There are different network topologies, physical and logical. Physical is the actual hardware layout, and logical is how the data moves through the hardware and the networks. Common types of this would be star, bus, ring, mesh, and hybrid. There are different network devices. These different devices are known as switches, routers, hubs, and NICs. Switches are better because they send data only to the intended destination. The second chapter was all about infrastructure and documentation. Structured cabling is ANSI/TIA 568. That is the standard cabling for reliability and consistency. Different cabling components are horizontal cabling, which connects workstations within 100 meters. Backbone cabling connects floors and buildings with fiber. And patch cables are short connections between these devices. Cable management is very important. That was one of the main things in this chapter. Using patch panels, labeling systems, and cable conduits are very important. Labeling systems make sure you know which wire is doing what and goes to where. And cable conduits protect these wires from being easily accessed because it is like a hard shell around the wire. The third chapter was about addressing. There are different addressing layers. The data link layer manages the MAC addresses. The network layer manages IP addresses using IPv4 and IPv6. I'll go into that later on the slide. The transport layer has different port numbers which identify different applications. And the application layer has domain and host names. Like I said earlier, IPv4 uses a 32-bit address, and IPv6 uses a 128-bit address and supports more devices and also auto configuration. DHCP dynamically assigns IPs, and NAT/PAT translates private IPs to a singular public IP for better internet access. The next chapter was about protocols. TCP/IP, their core protocols like TCP, UDP, IP, ICMP, ARP, and NDP. I'm going to go into these in more depth. TCP is a reliable connection-oriented protocol using a three-way handshake. UDP is unreliable but is faster for tasks like gaming. IP handles addressing and routing with IPv4 and IPv6. ICMP reports errors and connection issues used by ping. ARP and NDP translates IP addresses to MAC addresses. Lastly, Ethernet is the data link standard for local area network communication, which is efficient, cost-effective, and widely used. 99% of the time when you get your router from either, like, say, Xfinity, like I do for school, it's going to come with a Ethernet cord, which you plug into the back of the router, and you can plug it into, say, your gaming system, your laptop, anything that has an Ethernet port, and it makes the connection 10 times faster and stronger. Next chapter is about cabling. Frequency is the term used for signal cycles. This is the units of megahertz and gigahertz. Bandwidth is the term for the theoretical capacity, megabits per second and gigabytes per second. Throughput is the actual data rate. and there are many transmission flaws that can occur. Different of these could be noise, crosstalk, attenuation, and latency. Multiplexing combines multiple signals. There are different cable types as well. Coaxial is older but used for TV internet. Twisted pair is the most common in local area networks, and fiber optic is high speed and used for long distance. There are different connectors. RJ45 is the Ethernet connector. The F connector is for coax, and LC and SC is for fiber optic. Lastly, we're going to talk about wireless networks. Wireless local area networks transmit via radio frequencies, not cables. The wireless spectrum ranges from 9 kilohertz to 300 gigahertz. Different technologies are used with these wireless networks. RFID and NFC are for your short-range data exchange. The most common use of this you'll see is when you use Apple Pay or the tap chip on your card. Just tap it on the reader. Zigbee and Z-Wave are used for Internet of Things communication. Bluetooth is used for your personal area networking, whether you be connecting to your headphones, your car or truck, any kind of vehicle that has Bluetooth capabilities, stuff like that. And infrared, which is a line of sight data transfer. Antennas, there are two different ways antennas use their signals: directional, which is a focus signal, and omnidirectional, which is a 360-degree coverage. Wi-Fi standards: 802.11n/AC/AC, faster and more reliable using channel bonding, and MIMO. In conclusion, networks connect everything, whether it be simple wired setups or complex wireless Internet of Things systems. These are all examples of networking systems. It's everywhere. You're using it in your day-to-day life, no matter what. And it's important to understand how all these things work.